Alright y'all, today we are going to talk about end behavior and asymptotes. Definition. An asymptote is a line that a function approaches but does not touch. So what does this mean exactly? Well, let's look at the function that we've seen multiple times before today and haven't really been able to talk about in the proper terminology until now. We've seen this guy a few times before today. You'll recall that it's this function, f of x equals 1 over x. So this guy has two places where we approach but do not touch, right? We are getting really, really close to both the y-axis and the x-axis, but not touching. So this guy has two asymptotes. One is a vertical asymptote, at x equals 0, and one is a horizontal asymptote at y equals 0, right? So we have one asymptote at y equals 0 and one at x equals 0. They are named vertical for when they're vertical and horizontal for when they're horizontal. So why do we have this with this particular function? Well, I'm going to do this on scrap paper because it's not necessary to have in your notes, but let's think about what's happening with this function 1 over x. So if I were to put in 1, right, I get 1. This is asking us how many times can I fit 1 into 1? That's what division is doing, right? If I ask how many times can I fit 2 into 1, I can fit 2 into 1 half of a time, right? I can fit 10 into 1 0.1 times. I can fit 1/2 into 1 how many times? 2, right? I can fit 1/10 into 1 how many times? 10 times. As that number gets closer and closer to 0, what's happening? Let's say we put in 100. All of a sudden, we can fit 100 in there, right? We're getting, as we get closer to 0 with what we put in underneath, right? As our fraction gets really small, our output gets really big, right? So as I get closer and closer to 0, I'm getting larger. What happens if I try and think about 1 over 0, right? This is asking how many times does 0 fit into 1? What's the answer? We can fit as many zeros into 1 as we want, right? If something takes up no space, How many of them can you fit into a box? Infinitely many, right? So this is kind of infinity. But we also have to remember what's going on with this other side. If I make all of these negative, right, all of a sudden I have negative numbers, right? Okay, so that's our vertical asymptote. Let's think about this horizontal asymptote. So what's going on as we get really big to the left in the negative direction? As our x value gets bigger, our decimal is getting smaller, right? We're getting closer and closer to the x-axis. So if I were to put in a really large negative number, right, then we have a really small y value, right? And we're getting closer and closer and closer to 0. But there's no number large enough for us to actually reach 0. We can't divide 1 by something and get 0, right? Not even 0. So we will never touch the x-axis. So that's why we have these two asymptotes. What type of function is this? This guy is a rational function. This is not the only type of function that has an asymptote. One other type of function that we've seen so far is this guy. Does anyone remember what type of function this is? Hopefully we've been looking at our basic types of functions and we're starting to recognize them. This guy is a exponential function. Exponential functions have one asymptote and it's horizontal. Sometimes it's kind of tricky because it looks like this is getting really close to something, but usually when we have an asymptote, it'll be really clear that it's getting really close. Like this, if we can't really see, if this line isn't becoming basically straight as we move off the graph, then we can kind of assume that it's not an asymptote. Let's call this G. It's horizontal, right? We're getting really, really close to this horizontal line, which happens to be the x-axis. We never just say that the horizontal asymptote is 0. An asymptote is a line. Lines need to have a variable. So this is y equals 0, horizontal asymptote at y equals 0. It doesn't have to occur at the x-axis or the y-axis. Sometimes exponential functions will look like this. And here we are getting really, really close to kind of this line here. And let's say that this line is y equals 3. Right? So this function, maybe we'll call it h of x. H of x has a horizontal asymptote at y equals 3. Let's look at an example of this in our lab manual. This is from the lesson End Behavior and Asymptotes. Let's look at, first of all, graph E. And all I want us to do this first time around is look at where we have asymptotes. So what type of asymptote do we have here? Where are we getting really, really close to a line, but not touching it? Yeah, it's right along the bottom there, right? We're getting really, really close to that line but not touching. That is a horizontal or vertical asymptote. Horizontal asymptote. Horizontal asymptotes are x equals or y equals. Horizontal lines have all the same x or y values. They have all the same y values, right? They have all the same output values. So y equals, what is the y value that it occurs at? Looks like, it's very small, looks like -10. Awesome. Okay, let's look at, on the next page, graph H. So this is, again, another rational function. It looks like there are two places, one vertical and one horizontal, that we're getting really, really close to but not touching. Let's look at that horizontal asymptote first. So as we're looking at the left side of the function, it looks like we might be getting close to that second sort of grid line. Maybe we're getting really close to 4, but it's kind of hard to tell because it looks like we're a little bit above that line. So let's look at the right side. As we look at the right side, it's above that second grid line. So we know we're not approaching 4 because we're moving above that grid line over there. So looks like we're right in between those two grid lines, so that must be 5. So we must have a horizontal asymptote at y equals 5. Okay, so let's find the vertical asymptote. The vertical asymptote here, again, we are looking at where those two pieces of the function kind of line up. What line do they both converge on? So as we're looking at that left piece, looks like it's getting really, really close to that first grid line, which again is going to be -2. And then that piece on the right looks like it's getting really, really close to also that first grid line to the left of the y-axis, which is -2. So we can assume that we have a vertical asymptote at x equals -2. Great, okay. Let's go back to our notes really quickly to talk about end behavior. Okay, definition. End behavior is what the function does at the left and right ends of the graph. Let's look at an example here. Let's say we're looking at this really funky function. So what's going on as we move off the left and right sides of the graph? So first of all, as x goes off the graph to the left, the y values are approaching what? So as we move off the graph to the left, what's happening with the y values? Well, looks like the y values are getting really, really large, right? And if we have this arrow pointing up this way, we can assume that it's going to continue in that direction. So the y values are approaching what? What's a more mathematically accurate name for getting really large? They're approaching infinity, right? All right, let's look at the right side. As x goes off to the right, the y values approach what? As we move off the graph to the right, the y values are approaching, well, looks like we're getting really, really close to the x-axis, which is y equals 0. Essentially, at its core, this is what end behavior is asking. We have some more mathematically formal language to write about it, and we're going to do it in this way. As x approaches, we draw this arrow. It's usually not that long, but I want to fit the word approaches over the top just so that we kind of think about that that's what it means. So as x approaches negative infinity, so this first one, as we're saying, goes off to the left. What is happening to our x values? As we move to the left, that is the part of the graph where the x values are negative, right? And if we're talking about going off to the left kind of forever, right, that usually is represented by negative infinity, right? So as x approaches negative infinity, f of x approaches what? Well, we said our y values are approaching positive infinity, right? Sometimes it'll say y. So the way we would read this is as x approaches negative infinity, f of x approaches infinity, or y approaches infinity. Let's do the right side. So as x approaches, right, so we're thinking about the right, what's happening to the x values as we move off the graph to the right? They're getting really, really large, so they are approaching positive infinity. What did we say was happening to our y values there? Well, they're getting really, really close to, they're approaching 0. Okay, let's look at one more example of this. Let's say I've got some funky graph and it does a bunch of stuff and it doesn't really matter what it's doing, and then goes like this. Crazy graph. Probably a really funky polynomial. What's the end behavior here? So as x approaches negative infinity, what's going on? So as we move off the graph to the left, right, as our x values are getting larger in the negative direction, our y values are approaching, let's use y this time. Where are the y values going? To negative infinity. As x approaches positive infinity, as we move off the graph to the right, what's going on with these y values? They're also getting really, really negative, right? So y approaches negative infinity here as well. Awesome. Let's look back at those two examples that we talked about in the lab manual. So here we are looking at graph E in the lab manual once again. So let's talk about the end behavior of this function. So as x approaches negative infinity, and this is written out in words in the lab manual, but we are going to write it in our sort of nice math notation. As x approaches negative infinity, so as we move off the graph to the left, what's going on with the y values? They're getting really, really large, right? So y is approaching infinity. As x approaches positive infinity, right, as we move off the graph to the right, looks like we're kind of leveling off. And from last time when we were talking about our horizontal asymptote, where did we say we were leveling off? -10, right? So we can kind of see how asymptotes, particularly horizontal asymptotes, and end behavior are related. Okay, let's look back at graph H. So here, as x approaches -infinity, and this time let's use f of x. Just switching them up to show that we can interchange that notation, and both are correct. As x approaches -infinity, we are getting really, really close to, what did we say we were approaching off to the left there? Again, we want to look at that horizontal asymptote. We were approaching 5, right? F of x approaches 5. As x approaches positive infinity, f of x approaches, so again, as we're moving off the graph to the right, as x is getting really, really large, y is getting really, really close to, this time, again, it is 5. Okay, I believe that is all I have for y'all today. Very short lesson. Thanks for watching.